solving logarithmic equations. In this process, you're going to solve equations like you have in the past when you kind of undo the order of operations. But you're going to do that until you get the logarithm by itself. So we want to isolate the logarithm first. So you notice that there's a 7 in front, so that means 7 times this whole logarithm. So to reverse that, to cancel that order of operations, we'll divide by 7, because 7 divided by 7 is 1. And then we got to divide this side by 7 as well. So that leaves us with log 10 of 3x equals 15/7, which 15/7 is a little bit more than 2, because 14/7 would be 2. Alright, and then we want to write this in exponential form. So the base of our exponent is going to be the base of the logarithm, 10. The exponent is 15/7, and that is equal to 3x. So we're a lot closer to solving for x now. So now we need to divide by 3, and 10 to the 15/7 divided by 3 can all be typed in your calculator. You want to make sure you do that correctly though. So to do that, you want to type 10, and then there should be a little up button. You need to do parentheses 15 divided by 7. Make sure you close parentheses or it'll calculate your exponent wrong. 15/7 is your exponent, so keep that in parentheses. And then that whole thing will be divided by 3. And that should give you approximately 46.32. So this is a slightly more complicated logarithm because you have more than one that you have to get either isolated or to do something with. In this case, since you have 2 on one side of the equal sign, we can use a property of logarithms to combine those two. So the property that can combine the first one with the second one is called the addition property. And it says that if we have 2 logarithms added together, then we can take the log of the product of those 2 things. So we're going to multiply those 2 together. Alright, now when you multiply something like this, x minus 3 times x minus 2, remember you have to distribute or FOIL. So you have to do x times x, you have to do x times -2, and then you have to do -3 times x and -3 times -2. Okay, and again, like before, we just had a single logarithm that we wanted to isolate and then turn it into exponential form. In this case, we have 2 logarithms that are equal to each other. And there's another product that says when you have one log equal to another log, then the 2 things that you're taking the log of have to be equal to each other. It's called the inequality or the equality property. So that brings us to this equation, which is an equation that we can solve. Alright, so this gives us a quadratic equation because you have x squared here. There's a couple different ways you can solve a quadratic equation. You can try to factor it. You can use completing the square. You can use the quadratic formula. You can use some things like that. I believe this one is factorable, so we're going to try that first because it's usually the easiest. So in order to factor something, we want it to be equal to 0, so we need to subtract this 2x, so that's 0, and we need to subtract this 24, so that's 0. We got to do the same thing on this side. So this side equals 0, and then we have some like terms we can combine over here. There's x squared, and then we've got this -2x, -3x, and -2x. So that gives us -7x. And then we've got this 6 and -24. So that gives us -18. And then to factor that, we need two numbers that will multiply to give us negative 18 and add to give us negative 7. So 18, we can use 1 and 18, we can use 2 and 9, we can use 3 and 6. To get a negative 18, one of these is going to have to be negative. So I think we're going to go with negative 9 and then a positive 2. So negative 9 times 2 gives us negative 18, and negative 9 plus 2 gives us the negative 7. Alright, and then to take it a step further to solve this, we're going to set each factor equal to 0. So that would be x minus 9 equals 0 and x plus 2 equals 0. And then if we subtract 2 from both sides, we get x equals negative 2. And if we add 9 to both sides, we get x equals 9. So these are our two solutions to that logarithmic equation.